This is problem number 8 from section 5.1. It says for the given functions f of x equals 7 over x plus 4 and g of x equals 5 over x. Find f of g, g of f of f, g of g. All right. This is going to require a little bit of algebra work here, so let's make sure we use our space wisely. So f of g of x is equal to f with an input of g of x, which equals f with an input of 5 over x, right, the g function, which is equal to, now take 5 over x, plug it in for x here, and I end up with 7 over 5 over x plus 4. Now, because I have this x in the denominator, I actually want to get, like it's in the denominator of a denominator, I want to get this into a more simple form. I can do that by simply multiplying this whole fraction by x over x. So this is just making this simpler. This is, I've done the f of g of x part. I just need to simplify now. So I'm going to multiply by x over x here. When I do that, that gives me 7x on top. And on the bottom, I have x times 5 over x plus 4. When I distribute that, that's going to give you 7x over, the x cancels, the x's cancel here, so I have 5, and then x times 4 is plus 4x. So this is the more simple version of f of g of x. Part B, we have g of f of x. So we have g with an input of f of x. F of x is 7 over x plus 4, so we have g 7 over x plus 4. We can plug this 7 over x plus 4 in for the x in the g function. So we have 5 over 7 over x plus 4. Now we have technically a fraction on top. 5 over 1 would be the fraction divided by a fraction on the bottom. We flip the bottom and multiply. So it's going to be 5 over 1 times the reciprocal of this, which is x plus 4 over 7. Do a distribution here, and we end up with 5x plus 20 over 7. And that's the final expression for g of f of x. Part C, we want to do f of x, plugging the f function into itself. So we end up with f of x. The f function is 7 over x plus 4, so we end up with f of 7 over x plus 4. Take 7 over x plus 4, we're plugging it into the x part, so we have 7 over x plus 4 plus 4. Right, so we took the 7 over x plus 4, which was right here, and we put it into the x part of the f function. Now you see we have a denominator that's inside of another denominator. We're going to do the same thing we did up here, except for instead of multiplying by x over x, we'll multiply by x plus 4 over x plus 4. So multiply by x plus 4 over x plus 4. When we do that, we're going to get 7 x plus 4 on top over, this will be x plus 4 times 7 over x plus 4 plus 4 on the bottom. That's going to give you 7x plus 28 on top over, on the bottom, the x plus 4's cancel when I multiply it times this fraction because it's over 1. So that will cancel with this, leaving you just with 7. And then you take the x plus 4 and you multiply it times the 4. So plus 4x plus 4. That's going to equal 7x plus 28 over, distribute the 4, we get 7 plus 4x plus 16. Combine the 7 and the 16, you get 7x plus 28 over 4x plus 23. And that's the expression for f of x. Took a little algebra work to simplify it. I mean, we technically at this point right here did the f of x part, but then you need to kind of simplify it to get rid of that denominator there inside the denominator. Part D. G of x. That equals G of x, which is g of x is 5 over x, so I have g of 5 over x. So I'm inputting 5 over x now into its own function, so I'm going to have 5 over x. Again, this is a fraction on top because it's 5 over 1. On the bottom we have a fraction. We're going to flip and multiply, so this is 5 over 1 from the top times the reciprocal of the bottom, which is x over 5, leaving you just with the 5's cancel, x. And that's g of x.